Professor.
Hello, thank you for saying hello. Hello, hello. Okay, we're once. Oh, hold on one second. Okay, hello, hello. Sorry. Sorry, one second. Um, okay, sorry. Hello, hello. Good evening. Yes, hello. Okay, wait, more people are coming. More people. Okay. Hello, hello. Oh, a lot of video. Oh, cool, cool. I see many of you. This is great. This is great. Okay, so first of all, hello, Fahima. Hello, Kazi. And yeah, long time no see, seriously, and so disorienting. True, true that. Hello, Adriana. Hello, Charles. Hello, Kareem. Where do I go? Good evening, Cassandra. Good morning, Yulia. That's interesting. Oh, and that just reminded me of something actually. Oh, good evening. Yes. Oh, I'm getting confused. Wait, good, right. So good evening, Yulia. Hello, Diana. And yes, and good evening, Yulia. Hello, Sasha. Hello, Grisella. Grisella, sorry. God, it has been a long time because I used to be able to pronounce your names and now I'm not anymore. But good afternoon, Kwan. Okay, also, I think that's everybody who's here. Let's see. Wait, yes, Grisella. No, no. Oh, a lot more. And please, again, do private chat me or whatever. I may still be screwing up people's names and I apologize. So please do direct chat me. Also, let me just turn on the light. Hold on. Okay. Hello, Christina. Yes, thank you. Hello, Christina. And hi. Oh, no, wait. I am not pronouncing that name correctly. I remember that now. Wait, it is Noreen, I think. Wait. Noreen, I think. Oh, and hello. Yes, yes. Okay, good, good. Thank you. And hello, Janelle. Good. There was someone else. And Grisella, I'm so sorry, but am I saying it right? I think I tell me. Yes, yes. So that's awesome. Oh, and there are more people coming. More people coming. Hello, hello. So we will get rolling with the material in a second. Okay. All right. So logistical items first. Like, yeah, it's been a long time since we've had class. And I know that the schedule for this class is still kind of confusing, and I am making it confusing. So what I really appreciate is more than 2/3 of you got the message from me that today was one of those times that we weren't going to start till 4:30, and like more than 2/3 of you sent a yes back to me. Totally appreciate that. That just makes me feel like we're having some kind of communication. And those of you who sent the yes back, and maybe there are still a couple that I didn't see that I'll check. You all got 10 points for doing that, and I mean it, and I appreciate it. But also, I noticed that when I did teach my other class at 3 o'clock today, I don't think anybody from here showed up there. So I feel like even those of you who didn't send me yes, it seems like the message got through. That you did the right thing by showing up at 4:30 today. I appreciate it. Again, that's never going to happen on a Monday. Monday's always normal, as long as it's normal for John Jay. Occasionally, this will happen to us on Wednesdays. But when it does, I'm going to try to send you a notice like that, and I'll try to give you points so that we have the communication. So like next Wednesday will be normal. Next Wednesday, we will be here at 3:05. And so I'm not going to send out any message or anything. But one thing so I appreciate your rolling with all that. One thing that was confusing also, I didn't mean to make this confusing. Like I told all of you that at some point there is a video that you'll have to watch to make up for the 75 minutes of time that we missed today. What I tried to say in my announcement to you is that the video will be posted at some point, like within the week, and then you just have to watch it before the next class. I haven't posted the video yet. In other words, it is true at the beginning of the year, I was sort of hoping that I would often have that video posted before we even got to class time. And maybe sometimes I will be able to succeed in doing that. But I tried to clarify in the announcement today, like there will be a video. We'll watch it. It will make up for the instructional time. Like we were there for, not right. If you thought that it was posted before today, you're not crazy, because number one, that would be a good thing. It would make a lot more sense if I had posted the video before today. Number two, at the beginning of the year, I sort of probably indicated that that's what I was going to be hoping to do. But so it's not, you're not crazy and you're not confused, but the truth of the matter is I have not posted the video yet. I just haven't had time. Oh my God. Oh. Well, that's impressive and clever. Whoa. Wait, let me see. Wait, is that right? Oh, without realizing. Okay. So no, if you watch, and if anybody watched the 204 one, I don't know, it might have been very relevant and helpful, or it might have just been a total accidental one. Oh, good. All right, then that probably really benefit. If anybody did watch a 204 one on the same homework, good for you. Then you probably did save yourself a lot of heartache. And you certainly, and if you did that, any of you who watched the 204, a physics 204 video on the same homework, that's good enough for me. Like the truth is I was even tempted to, and maybe I will just call that, I don't know. That's good enough. If you did that, and if you're panicked and want to watch the video tonight, you can do that. I did mean to make a video specifically for you guys, and I still do mean to do that. I just didn't get it up in time for today. So if you didn't find it, it's not your confusion, it's mine. I will tell you as soon as I put it up, I will notify everybody where it is exactly, and like what it's called and all of that. Okay, no, but yes, if you did watch a 204 one and it worked for you, then great. But no, I expected that for many people, it would be confusing to watch a 204 one. So that's not what I expected. I expect to make one for you guys. It is my bad that I haven't made it yet. You are not behind. I will tell you when, when I make it, it's time to watch it. We're just going to go, we just have to make up the time. That's all. So as long as you responded, yes, you got 10 points. Even if you didn't respond, yes, if you got here to this class now and you're here, then you're in the right place at the right time. I appreciate that. So I will post a video. I will let you know. Sorry for the confusion. Thank you for understanding. Cool. Okay. No, if it worked for you. No, I can see how it might have worked for some people and not for others. I will make a video for you guys that is not confusing. But if you already did watch a 204 one and it worked, then that is fine. Okay, but it's my bad. It's totally my bad. Okay, so but now I do want to start going over our material and going over homework one. We haven't seen each other. Oh, sorry, Kazi. Yes. Question or Kazi question or no? Oh, you were just right. Okay. Any questions? No. Okay. Oh, no, sorry. I cannot hear you. So you are asking a question, but I can't hear. Oh, okay. Okay. So when Kazi comes back, we'll get her question. So I want to start going over homework one. We're obviously not going to get all, we only have, 75 minutes now, but that's okay. Okay, Kazi, go for it.
Can you hear me now?
Yes, totally. Yes.
Sorry, I've been having issues with my laptop. My question is regarding the homework. I wanted to know, what do you expect out of us in terms of our math competency? Because I saw in the last homework how we had to integrate a second order differential. And to my understanding, that's even beyond the scope of Calc 2. So I'm just wondering what you expect us to know. The reason I got the homework was because I watched a previous video of yours online from your 2020 class, but if I hadn't watched that video, I wouldn't have been able to do the homework at all.
Okay, wait, all valid questions and stuff. I do not expect you to have differential equations in your background. I totally understand that. You are not expected to have differential equations in your background. We are going to show you some stuff, Joe and I. I mean, we are here to teach you some math and some things that you are going to learn in this course. So by the time you get to the very last question of homework 1, by the time you get to the very last question, it does require some thought. And excuse me for 1 second. Yes.
We're going to the arcade now, and instead of going to the arcade with you tomorrow, we're going on Friday so we can all come.
Oh, okay. Thank you for. Okay.
So yeah, I just wanted to say bye.
Oh, hold on 1 second. That is so sweet of you to explain all that to me. Okay.
Make sure no intruders come and the fish tank is all clean.
Okay. Thanks for explaining that. Wow.
Even if the fish aren't here, you have to take care of the tank. It's fragile. It's made of glass.
You're totally correct. So.
And if it breaks, you have to clean up. I'm not making it. It's not my job to clean up.
Well, thank you for explaining.
Mommy, can we go? Can we go off the driveway because we can see Dad? Hug. And also bring Sticky in. Actually, I'm gonna let you. I want you to stay with Sticky.
Okay.
Wait, can you come?
I can't. I gotta teach.
Oh, I thought you were done.
I'm not quite done yet, but maybe I'll try to meet you right when I'm done.
Yeah, we have 32 minutes, so you have like a lot of minutes.
32 minutes to
until
get
we
there?
leave. Until we leave. When we get there, we have 32 minutes to play.
Oh, I see. Okay, maybe I'll see if I can. Okay, thank you very much for telling me that.
Oh yeah, 32 minutes.
Okay, interesting. Okay, sorry. Okay,
Mommy, come on.
okay, sorry.
Look after my stick. Make sure he
Oh,
doesn't
thank
go
you.
away and keep him next to you at all times.
Got it.
He's
Got
my
it.
special stick.
Got
His
it.
name is Plussy
I like it.
because he has a plus on it.
Got
If
it.
you ever lose him, he has a plus on it. I'll show you.
Okay. Okay. Now I do.
See the plus?
Oh, I totally see. Great. All right. Thank you for telling me all
You
this.
might get
Maybe-
confused because it's kind of blended in.
Got it. Okay.
We're doing a
Right.
quick one.
Family
Okay,
hug,
got it, okay.
family hug.
Okay. Okay.
All right. See you in just a little
See you guys.
bit.
Love you guys.
Mommy,
Okay.
I don't.
Okay.
I don't put on.
So, okay. Did not see that coming. Sorry. Okay. That was not. Okay. I think he does not know. He does know. Okay. Anyway. Oh, thank you. Okay. I totally appreciate it. All right. Now I'm all in. Okay. I'm going to go. Did not see that. Okay. But I do respect also Kazi's question. Let me go back to that. The very last question on the homework is hard, no question. All the questions up until that point are also hard. Okay, I have a lot to say about this. I'm going to sound a little bit defensive. I don't need to be. It's a very legitimate question what Kazi's asking. It gets us into, I mean, there's a lot of things I want to say about it. Let me back all. No, I don't expect anybody to have technically, to be really technically, we don't even require or expect you to have calculus. That is true, what Kazi is implying. Now, the truth is, in reality, we know it. I mean, requirements have changed. The program has changed. We know that most of you have had calculus for other reasons, but technically it's not required for this class. I want to make that clear. When you come into this class, we do not expect you or to have calculus in your background. We don't expect in the sense of we don't hold you responsible for that. That is true, what Kazi is saying. It's also true that calculus is a big part of physics. What we expect is that you're comfortable with math, that you don't hate math, or you're like used to doing math, whatever, and just like you have science in your background before you come to physics, but we can't expect you to have physics. Well, I mean, we do actually expect you to have physics 101 in your background, but even before you come to 101, right? We can't expect you to have physics, but we expect you to have science. Therefore, we expect by the time you get to 101, we can teach you some physics that like you didn't already have, right? Like, I mean, in a way, like duh, like that's what it's for. And similarly, and I'm walking a fine line here, but We don't expect you guys to come in with calculus. We don't want you guys to come in with calculus necessarily, but we expect to teach you a little bit of calculus here. I mean, I don't want to scare anybody or anything, but you know, a little bit of math is part of physics, or a little bit of physics is part of math. We're going to teach you some things now, and some of them are going to be relevant for that very last question on homework 1. But I want to say this very carefully, like, because it's a very valid question what Kazi's asking. So let me be more expansive for a moment. We want to teach you how to learn. We want to teach you guys how to know what to do when you don't know what to do. Like, ultimately, i.e., we want to make you smarter. And I mean that. I'm not saying you're not very smart already, but I'm saying, especially in this day and age, with Google, with Wikipedia, with Khan Academy, with 3 brown, 1 blue, with Chegg, with everything that is at everybody's fingertips on the web, and with people as smart as you guys are, and I mean that, and as motivated and as hardworking as you are, we're not actually here just to give you knowledge, right? We're not actually just here to just impart information to you, because the fact of the matter is you guys can get information on your own a lot faster and a lot better and a lot more comfortably without us. You don't want to pay all this tuition money to us for us just to be a glorified Google service to you. And I'm saying this to everybody. I'm trying to make a larger point here because Kazi's tapping into something that's a very legitimate, like, larger concern that comes up in different ways in these classes. What we feel that we're here to do, particularly in physics, is to actually prepare you for research as scientists, prepare you, you know, for higher academic or career paths in science, which means learning how to do original thought, right? We're not here to give you old information. You can do that without us. We're here to show you how to get new information on your own or invent new information on your own. We're here to teach you how to solve problems that you don't already know how to solve, right? Now, that's true for everybody and everything in the class. So what that means is when we assign homework to you guys, so this, I'm now going to make a larger point about homework. We expect you to try it before we explain it. You try it. You turn in the draft that you've tried, you get points for how you're trying, right? And then, I mean this seriously. I may have already made this clear, but we haven't met for a couple of weeks and you haven't gotten a homework back yet or a second homework, so you don't know yet necessarily. When we assign a homework, it's not like old traditional classes where we've explained exercises 1 through 89 odd, and now you go off and prove that you get the PowerPoint presentation that we just did and you solve exercises 1 through 89 odd. No, when we assign you a homework, we're actually asking you to do whatever it takes to try to figure out what's on the homework as best as you can, either by remembering certain things from Physics 101, which actually a lot of that homework was actually based on, or by using the principles that we've said in the class, or by looking things up, and or by helping each other. Absolutely, definitely helping each other. And you try to solve the new problems that are on the homework as best as you can, and you get points for doing the problem solving methods and trying. It's totally conceivable, as you get more and more used to our homeworks, it's totally conceivable that someone can get full credit, all the points on a homework, while still getting all the answers wrong. Please note that. It's also conceivable to have all the answers right and not get all the full points, because what you're getting points for is attempt at methods. But now here's the real, and again, I know I sound really defensive here. I really don't mean to. I just know this is a very important question that Kazi's asking, and I know it's coming from a place of slight concern. So I'm ultimately want to alleviate these concerns. When you hand in a homework to us, what you're handing in is a first draft. Like, honestly, you're handing in your attempt to solve the problems and to get as many points as you can on the problems by trying as best as you can. Then we start going over the problems and showing you things, and hopefully showing you how to get better and better at solving problems that you have not solved before. At any and every moment, all of you, maybe I made this clear last time, maybe I didn't. At any and every given moment, all of you can and should just keep on handing back in the homework with updates and revisions, either based on comments that I make on homework or whatever we do in class. That is to say, eventually we go over the whole homework, we give all the answers and stuff. You still, at that point, even after I've gone over the whole thing, you can still turn around and revise or update your homework draft, turn it in, and get back all the rest of the points that you might not have gotten on the first draft. Let me make this clear to everybody. Every single homework is has a point value. It is entirely encouraged and possible, and you all can get all the points on the homework, on every homework, even if you don't get them all the first time, even if Google Classroom says you're late or whatever. That's not meaningful to me. When we say a homework is worth 20 points, we're saying as long as you eventually do everything that we're asking here, as long as you eventually benefit either from our comments on the homework or what we actually go over in class, then you have all the time in the world to then eventually show that you get what's going on in the class and get all the points. The first time you hand in the homework is your first draft or your first attempt. And sure, for some people, depending on who you are or how strong you feel or how fast you feel, you might be able to get all the points in the first draft and then move on. But in other words, what I'm really saying to everybody is, we don't want to teach you and then quiz you. We want to get you in the habit of trying to solve things. And then we talk about how better to solve them. And we feel that it's a fair thing to do that because you're never going to be punished for anything you got wrong the first time. You can eventually get all the points, even if it means waiting till you getting through all of the classes where we go over it. We want you guys to get better at doing things that you don't know how to do, because that's what real science research is. We want to teach you what to do when you don't know what to do. So now, to be more concrete, we're going to start going over homework 1 today. The truth is, all of the questions on homework 1 actually are solvable from whatever stuff you studied in physics 1. The truth is that most of homework 1 is a transition or review or recollection of physics that you in principle can do from everything you did in physics 101 and or with a textbook next to you or with a friend next to you. The very last question builds from all of the prior questions and does get into some hard territory that we want to show you. But we're definitely not expecting that you walked in with differential equations or anything like that. We're definitely expecting that you would try the homework, do most of it, and make an attempt at question 9 or the very last question and see what you see and see what you don't see. And then that's it. So I don't know if that totally answers that, but no, we're not expecting that you have calculus coming in. We expect that. What I really think in my heart too, final thing on this too, because okay, the relationship between math and physics is a tricky one and does stress people out sometimes. I know that in the college, we do have a bunch of math prerequisites for a bunch of science courses. That is what it is, good or bad. In my heart of hearts, it would be just as logical. If it were up to me, it would be just as logical and just as productive, if not more, if we made physics prerequisites for math classes. That is what I'm trying to say is this. I know calculus now, and I know some physics, but I don't know physics because I entered physics with calculus under my belt. I learned my calculus through physics. Like for me, calculus never made any sense. I mean, I took the classes that I was supposed to take and I got by just like many of you. And I did the equations and stuff like that, the procedures that I was taught in calculus class, but I didn't understand it at all. And I didn't feel that I understood it. I didn't like it. I didn't know what I was doing. I didn't feel confident. I just sort of did what I was supposed to do to an extent. And sometimes it worked out and sometimes it didn't. But then eventually in physics, where I was supposed to use all this calculus, then they started breaking down and explaining what the calculus was about and making us do it, whether they called it calculus or not. They started breaking down the procedures and making us do it in a physics context. And that's when I started retroactively understanding calculus. If someone had told me that what I was doing was calculus, I might have run and said, oh my God, wait, I don't want any more calculus. But they didn't. They just like did stuff. And we did stuff that worked, that made sense. And then it turned out what that was calculus. That's going to happen a little bit in this class. We're going to show you things that make sense, that go step by step from steps that you'll figure out on your own. And then it's going to turn out that some of what we're doing, you might call calculus. And maybe it'll even shed light for some of you on calculus courses that some of you happen to have taken. But we are not expecting that you have calculus under your belt? No. I mean, last thing to say, actually, truthfully, honestly, I often would rather get people in here that don't have people that have taken a lot of calculus classes ultimately often end up being corrupted by them anyway. They end up not either liking calculus or just knowing how to follow rote procedures and not knowing what it's about. Like, I'd rather have a fresh slate with a lot of you anyway. So we are not expecting prior knowledge. We are expecting a willingness to try to go step by step and do things logically and work with us, which I'm going to shut up in a minute and start going over homework one. I'm going to start going over homework one now or in a moment. What I want to assure all of you is, even if you didn't know how to do it when you first turned, like, you can still keep turning it in based on anything I do here. You all can get all the points, even if you wait till I explain everything and then you turn it in. That's not cheating. That's part of the process. I don't know if that helped at all. I know that was a very long answer. I'm sorry, but it is a very legitimate question. Oh, thank you so much. I really appreciate that, Kazi. Okay, thank you for publicly saying you, because I know, thank you for saying you understand, because I know that, okay, cool. Okay, that means a lot. Oh, okay, no, cool. I appreciate it. And because I know it sound, yes, no, cool. Okay. So, and thank you for what you said about my family. I appreciate it. Okay, so this class ends. So we're going to start going over the thing now. Okay, so we're going to start going over the thing. Yes, right. So, and I'm going to show you the method too. Anyway, whatever. I'm going to show you things. And there's not going to be any new. And I know we're so. Oh, okay, cool. Well, you guys are so nice. Oh my God. And I do mean it again. I mean, I know I do sound offensive but the goal of this class is to increase intellectual intensity and reduce stress. For the longest time, I thought that in order to be intense, I had to be stressed all the time. Or I thought if I wasn't stressed, then I wasn't intense. They're not the same thing. We can be intense without being, we don't want you to be stressed. We're not here to give you unnecessary stress. We are here to get smarter and all that. But anyway, okay, I think you get it. So I'm going to start going over the homework, but you're not going to have any new homework for a while because I know there's so much homework I do need to go over. Okay, why is this thing not? Okay, so here we go. And frankly, this is also why I think it's better. I'm not going to say this is the reason. It's better that I start this with you as a group, and then I'll make a video where I continue the other 75 minutes. I think it is better that we start this with a group, not with just a raw video anyway. I mean, I won't always be able to do that, but okay.
I think we went over the homework number 1 last time. We didn't went over the number 2 though.
Oh, thank you. Oh, okay, thank you. We did. All right, so we did. Okay, great. Okay, so I'll skip to number 2. Thank you. I didn't. It's been so long.
2 and 3 to do. Yeah.
Oh, so I'm sorry. Wait, 2 or 3?
We still did not do the homework number 2 and number 3.
2 and 3. Okay. Wait, you mean question 2 and 3 on the homework?
No,
right?
homework 2 on our Google Classroom is a thing on the spring. So I think that's where the confusion is.
Right.
Oh, okay. Yeah, I'm sorry.
No. You're right. I'm the one that's wrong.
On the spring, yeah.
No, you're right. Because I forgot, because homework 1 was on thingy thing. I'm sorry. I'm the one causing the confusion. You're absolutely right. Okay. Thank you. Yes. So this is what I think we're going. So we're going over this.
Also, Professor, just to clarify, the homework 3 is due next week, right? Since we didn't have class last week.
Correct. And
Thank
honestly, yeah, no problem. Yeah. Yes. Yeah. But honestly, to all of you, we're not going to finish going over homework 1 today. Like, that's clear, right? So again, also just in terms of this whole homework, your job is always to be a little bit ahead of me. A little bit ahead. Like, you always want to be working on something that we haven't worked on yet in class so that you can be trying it and all that, but you don't have to be very ahead of me. So even though technically homework 3 might be due next week, we're not even up to homework 2 yet. So you guys can take a breather, and whether I update in Google Classroom or not, like, as long as you've done something more than we've gone over in class, then you're prepared for class, if you know what I'm saying. So even if you're not up to 3 yet, don't worry. But like, I wouldn't even start worrying about 3 if you don't want to, until you start seeing evidence that I'm going over 2 in class. It's like that. I always want you to be a little bit ahead of me so that you're trying something that you haven't tried before, but just that, it's not meant to be crazy. Okay, yeah, but yeah. All right, so. Um, okay. Okay. Now, what I'm going to start, start going over this. What I'm doing here, I'm not just going to give you answers. I'm going to try to solve these problems with the method of problem solving that I'm ultimately expecting you guys to do on your homework. I'm going to show you a method now of how to figure out things that you don't know. I'm trying to show you a method here of what to do when you don't know what to do. There's no way I can expect that you would have known this before you started the class. So even if you didn't get, so again, even if you lost points or whatever on the first homework, or just turn it back in and you'll get the points back. Don't take it as a punishment or a criticism or anything. But I'm going to show you now a 5-point method for how to solve problems. And I do want you to do, I mean, a 5-step method, excuse me. And I do want you to do this method even when you think you already know an answer. In fact, to be honest, I especially, the more you do think you know what to do, the more you do think you see an answer, I still want, all the more reason I want you to do out this method of solving problems, of showing your work, in other words, because the more you get in the habit of doing this method of problem solving, when you do think you know what's going on, the more you'll have a method at your fingertips to follow when you don't know what's going on. Okay, so I'm going to show you this method now as I get the answers. And it involves 5 steps. It involves 5 steps that have like acronyms in them. So if you ever see these acronyms on your homework, you'll know what they mean. Okay, in other words, okay, question one, I believe was, so question 1 was at t equals 0. At the very first instant of this situation, what is the force being exerted by the spring on the mass, right? I believe that is question 1, right? Now notice what I've done here already. Like I'm pretending I'm you now doing my homework, okay, or taking an exam. What I've done is I've got the homework sheet like in front of me somewhere, but I'm not writing on the homework sheet, right? I've taken out a fresh piece of paper. I'm starting to write out things on the fresh piece of paper. The very first thing I did here is I drew a diagram and wrote all the basic facts, the givens of the problem, even though it's already on the sheet. I know that. I've sort of recopied, or I've sort of put it in my own handwriting. I've written down a diagram and all the basic facts. That's what you need to do. Even if I've already given you a diagram, let that be the reminder that you need to do it. If I haven't given you a diagram, then that doesn't mean you're off the hook. All the more reason. What we start every problem with is a diagram and the fact patterns. And so in fact, and that's step 1 of any problem solving method, right? So I'm literally going to write, so if I ever write on your homework, DFP question mark, and like take off 2 points or something, what that stands for is this, is diagram and fact pattern, which really means the givens. And again, let me say, if you don't know how to solve a problem, this is the first thing you should do to start solving it. If you do know how to solve a problem, do this, all the more reason, because then you'll have it as a habit for when you don't know what to do. So this is the first thing we do, is always give the diagram and the fact pattern, or in other words, the givens. And how do we give the givens? We generally give them as labels on the diagram. That's sort of the point of the diagram, fact pattern. In other words, the givens. Okay, so this is the first thing I expect people to do when they're solving a problem. And again, if I ever write DFP -2 or something, it's because you didn't do this. Okay. Then the next thing, sorry. Sorry, this is the diagram and the fact pattern, right? Now, the next thing I did notice on my blank piece of paper, I'm handing in the homework, right? I mean, I've got the homework sheet next to me, but I'm handing in the homework, and on my blank piece of paper, you notice I wrote question 1 or Q1 or whatever, and I actually wrote the question out. Like I didn't write all the English words. I didn't copy and paste Yaverbaum's font, but in as concise a manner as possible, with the minimum amount of information necessary. I conveyed the question right here. I wrote at t equals 0, f equals question mark. Like that's the question, right? I mean, it's a concise version of the question, but it is the question. It is the second step that all of you must do every time you're doing the homework, even if you think you know the question, even if you think you could do the answer in your head, which some people probably did here. Nonetheless, what I'm insisting is before you start solving or showing your work, show me what the question is. And so what if I already know it? I'm asking you, and don't copy paste. Show me in your words that you know what the question is. You can't believe what an important skill this is. It seems stupid and a waste of time to do when you think you know how to get the answer, but it's a crucial step to do when you don't know how to get the answer, is write down what the question is. So this is step number 2. And if ever and again, it's what to do when you're doing the homework, even if you don't know the physics, even if you're thinking, oh my God, he's asking me all this calculus or something. The first thing you do is you write down the diagram and the fact pattern. And the second thing, if I ever write on your homework, sorry, if you ever see on your homework anywhere, WIQ, that stands for what is the question. If I ever write WIQ question mark and I take off like 2 points, it's because I'm saying you just dove in and started answering the question, but I don't know what the question is. Okay. And it happens a lot. I'm actually really, really obsessive about this because, again, let me just say, whenever people do know the question or know the answer, this seems like such a waste of time to them. They feel like I'm treating them like a kindergartner or something. But I'm telling you that if you don't know what a question, how to answer a question, and you're in that state where you're like, I have no idea what is even going on here. Is he expecting me to know calculus? Like what? You can't believe how much mileage you can get by actually first trying to break down and state what the question is. It makes all the difference in the world. So the second thing you do is, what is the question? You put the question. Now, also, by the way, you'll notice that this whole homework sheet has one big diagram with facts and then a bunch of problems after it. I'm not saying that you have to recopy the diagram each time. You can just keep referring, you can just like write a line or whatever, see above. You don't have to you don't have to keep recopying the diagram. But for every new question, you absolutely have to tell me the question in as concise a way as you can, but show me that you know what the question is, right? That's step number 2. So I did it. I wrote at t equals 0, f equals question mark. Then the next step, going to the next page here. So again, this is a guide to how to do the homework. If you didn't do the first homework this way already, you won't be punished. Don't worry about that. But so then the next thing you do, all right. Well, the next thing you do always, whether you know what you're doing or not, is GDP. GDP, which stands for, well, I guess sometimes it stands for gross domestic product, but here it stands for general. Yeah, right. And I tried to make these acronyms like sort of easy to remember in that sense, but yeah, I mean, it does look like gross. But anyway, what it stands for here is general definitions and principles. This is getting a little bit messy here, but this is a really important step. This is a key step to do, especially if you don't think you know what you're doing. This is a key step to do. And it's honestly, it's a step that people skip all the time. Like what this whole method I'm trying to do is I'm trying to show you how to show me work, right? The truth of the matter is what a lot of people sort of know how to show work in science or math, but what they're used to, by showing work, what a lot of people mean is they showed how they plugged into equations. But what we all know is like the real difficulty of physics, like what a lot of people will say legitimately is, I know what to do when he shows me, and I know once you give me the equation, I know how to plug in and solve, but I just don't ever know what equation to use. People say that all the time. Or they'll say, I know how to do the physics, like I understand what he's saying in class, but I don't know how to start the homework. What they're really saying is they know how to plug and chug equations. They don't know which equations to use. Well, that really means they know how to do math, maybe, but they don't know how to do physics. I mean, put another way, people often complain about how much math there is in physics, but actually the math is actually the easy part for most people. When in doubt, they just rely on the math, which is like not actually a stress, especially for groups of your, like the programs that you guys are in, your math is not your problem usually. But people skip, they skip the step where they actually make a choice about what equation to use. And the way to know is this. We start with triple equal signs and move to double equal signs. Have I spoken to people about triple equal signs versus double? Did we talk about that last class? Have I ever mentioned a triple equal sign versus a double equal sign?
No.
No. Okay. Okay. So I'm going to go to the next page. I'll turn this page back in a second if you want me to, but there's a big difference. There's two types of equals in physics. I mean, in life, but they're particularly relevant in physics. There are really two different types of equals in life. And it's really, really helps to keep them straight, to keep them different. Equal with a double equal sign just means equal, kind of like the way you expect, equal as by discovery or by outcome. That's supposed to say or, sorry, that's a stylus isn't really much. So like PV equals nRT from chemistry, that's a double equal sign because, I mean, you might even call that a law, but it's like a law that we discovered after tons and tons of experiments in the lab. We came to decide that generally speaking, the pressure times the volume of some ideal gas equals the number of particles times the temperature, times some constant. That's a double equal sign because that's a discovery. It didn't have to be that way. We didn't always know it was that way. We sort of found it out in the lab, and someday we might find out some more detailed version of that that makes that a little bit less true, or you know, we might shed more details on that equality. But a triple equal sign is not something we discover in the lab. And a triple equal sign means equal by definition, like average velocity equals displacement over time. Or if you like, average speed equals distance over time, like that's an equation, right, from physics 1. Average velocity equals displacement over time. We did not discover that in a lab. And therefore, we didn't discover that it's true in a lab. Therefore, we're never going to discover in any lab that it's not true. It's true by definition. When we say that average velocity equals displacement over time, we're just saying that instead of saying displacement divided by time all the time, because that takes a lot of time to say, we're just inventing a new term. We're saying from now on, instead of saying displacement over time, we're just going to use the shorthand and call it average velocity, right? It's just a definition. You don't need instruments or measuring equipment to find out whether it's true or false. All you need is a dictionary. Now, it's really a lot more equations or formulas, if you like, a lot more equations in science than you might imagine are in fact definitions rather than discoveries. And whenever we have an equation in physics that's a definition, not a discovery, it's really good to highlight that fact by using a triple equal sign, because the fact of the matter is, if a definition is ever right, if you have any, like for example, average velocity equals displacement over time, if you ever understand that at all and you ever think it's right at all, then you always understand it and it's always right. Like that's the thing about definitions, right? They never fail you. If you get them at all, if you speak the language, then they're ironclad. I mean, for example, I mean, not to beat a dead horse, but I'm going to, because this is like, so, well, this is a really important distinction. From now on, we're going to distinguish. We're going to use sometimes double equal signs when that's all that's applying, but sometimes we're going to use triple equal sign whenever we have an equality by definition, because it's so reliable. I mean, quick example of that is like if I say, you know, I went to Portland, Maine the other day, and I saw, and in Portland, Maine, they have this cool cafe where you can order like 3-sided squares for breakfast. And if I said that to you guys, I'm like, really? They have these 3-sided squares in a cafe in Portland. And if you were like, wait, roll back that tape, say that again. You have around, they have what? And I'm like, they have 3-sided squares in this cafe in Portland. It's totally awesome. You would be very right to be like, could you put down the crack pipe while you're speaking? Like what? No, they don't have like either I didn't hear something right or you're crazy because they didn't have 3-sided squares. And if I said to you like, oh, really? They didn't? Have you ever been to Portland, Maine? Have you ever been? Like if I said that, like you've never been to Portland, Maine, what do you know? You've tested every square in the whole country. You know, you'd be like, I don't have to test square. Like, it's not a matter of that, dude. Like, I don't care that I've never been to Portland, Maine. I don't care that I've never done the experiment. It's not a matter of experiment. Square means 4-sided figure. Like, it's just a contradict, right? You see what I'm saying, right? Like, you just know that I'm wrong if I said there's a 3-sided square. Similarly, if I said, you know, the other day I saw a 4-sided square, you'd be like, yeah, I totally believe you. I don't even care where you were. And I don't care how crazy you are. I believe that you saw a 4-sided square. I know for a fact you did. I would bet a ton of money that if you saw a square, it was like, you're that certain. Definitions are that certain. So to come back to this, what I'm saying is when we're solving a problem in physics, before we like first we write a diagram or the facts, then we write down the question itself. Then before we start crunching numbers and jumping straight to numerical details or units, then we write down some kind of triple equal sign thing. We write down a general, either a definition or a general principle or a law. We write down, in other words, we don't put the numbers yet. And this takes people some getting used to. This resists a habit that a lot of people have developed by this point in science, which is to jump to the numbers. Don't do that. What I'm ultimately saying is, the best habit, it sounds obvious when we say it, but it's exactly what we don't do when we panic, is always when you're doing homework, when you're taking an exam, when you're doing a new research thing for physics, always start with something true and then do a bunch of work to make it relevant, right? And we're going to see that in 1 second. Well, I'll do it in this example here in a minute, but start with truth and then try to make it relevant. Because truth is truth. And if you write down something true first, even if you don't know what next step to go to, even if you then get stuck and you can't get any farther because you don't know the numbers or you don't know the math, if you've written something true, then you have gotten points right there if you want to be concrete about it. If it's on homework or an exam, if you write down something true, then it's true and you're going to get points for it. So even if you're stuck now, you've already gotten some points. If you try, what people do when they panic in exams or in homework, when they think they don't know what to do, what they'll often do is scramble to start writing things down that they think are relevant. Like, oh, he's asking for the force. Force has something to do with the displacement. He said the displacement is 0.15. So I'm going to write down 0.15. And then if you start with what you think is relevant and then try to make it true, and that's what people do when they panic, they don't realize it, but that's what they do. When they panic or they think they don't know what's going on, they just scramble for things that are relevant and then they try to make them true, but that's ass backwards. You can't turn falsity into truth. And if you start with something relevant, but that isn't necessarily true, you don't necessarily get points. If you get stuck there, you got no. All right. Yeah, sir. Yeah, no, totally. Awesome. Thank you. No, I appreciate that, Anna, because honestly, this is one of my little secret. Like, I'm glad you see that this is significant. It sounds so obvious, but it's exactly what people don't do, by the way, in politics and political debates. And so watch, this is exactly the rule that people violate all the time. But okay, so thank you for so I do think this is, and it's exactly what to do when you're about, yeah, totally. I'm so psyched. So at least one person gets it. So let me show you the example of what I mean here in this first case, in the question of the homework. And I know that a lot of you probably got the answer right to the first question. Hopefully the first question isn't so hard or something, but here's the method that I'm saying. We drew the diagram. We wrote down what is the question, which is what's the force at t equals 0, right? Now what I'm going to do for step 3, before I start plugging in numbers, I'm going to write down something about force, like it's asking me to solve for F. So I'm going to write down something about F. I'm going to write down something without numbers, something that's always true about F. Maybe at this point, I might have to look up on the web. Like I might have to look in my notes from physics 1. Like maybe I have them, maybe I don't, or I might have to ask a friend, but at least I know what to look up now. I got to look up something about force as exerted by a spring, right? It turns out the thing I'm going to write down here. So here, continuing. I'm going to write down right now, in a way, I'm saying write down the equation, but you'd be surprised, especially because people often think they don't know what equation to use, and that's why they're stuck. If you follow this method, you'll see that the equation to use is just write down. It's basically just like define or make a general statement about whatever is the most relevant term in the question. So by writing down that the question was F equals question mark, it sort of signals our brain, well, we better write down. So in other words, what I'm saying is I'm looking for F. So I write something that's always true about F, what, at least on a spring. F always equals negative Kx. I don't care what the numbers of this problem are. F always equals negative Kx. This, and it's almost a triple equal sign. It's not maybe, well, for the force of the spring, I guess it is a triple equal. As long as by force we mean the force on a spring, then it is a triple equal sign. So now I go to step 4. Now I go to step 4. So if I ever write on your homework jjP and I take off points, I'm saying, hold on, before you go to numbers, write down something true before you get relevant, write down something general before you write down something numerical. And then we go to the next stage, which is PAW, and that stands for particular application and work. This step 4 is now the part that people generally think of as the work. And I'm saying there's 3 steps you do before you even get to this work, but this is now where, okay, now we have our general statement about force. So now we say, okay, here in this particular application, so this is where the numbers come in. We're going to now apply the general truth to this particular application. And we would say something like, if we were doing the homework here, K equals 200 newtons per meter, and X at t equals 0, X equals 0.5 meters. Right. So here, and I can go back to the page if you want. So we say here. Right. So, okay. And I'm including my units. Now being a scientist, I'm plugging in the numbers that are appropriate. I'm including my units. I'm being careful about the units. Okay, and I'm now going to do the math or whatever, the calculation. And so I get to my final step of the whole problem solving method, step 5. FAC, which stands for like facts, I guess, but it stands for final answer circled. Like make a point, or it could be highlighted or boldfaced, but make a clear point of your final answer. So literally in this case, so final answer equals negative. Okay, couple of things. 5:20. Oh, so class ends in 5 minutes, right? Go ahead. No. Oh no. It ends in 20 minutes. Okay, we have till 5:45, right? Okay, okay. Oh, yes. Okay. So my final answer is negative 30 newtons, which means, as Yulia is pointing out, like the negative means to the left. So so she's totally right that that's what it means. The negative sign is a direction. Strictly speaking, we could either say negative 30 newtons, or we could say 30 newtons to the left, like one means the other. So we don't technically probably have to say both. But yes, I totally agree with Yulia that it's a direction thing. Now let me pause for it. So, and that is the answer to number one. Like, I know I spent all this time now, like an hour, and all I've given you is one answer. I realize that. There's a number of reasons for this. And hopefully most of you did get this one right, or hopefully you'll see this isn't like a hugely difficult, this first question. And the questions do get progressively more difficult. They build off one another. But this one, you had to basically know one thing, which is Hooke's law for a spring. Here's the thing. I know many of you could just basically do this in your head. Like, for many of you, you could get this answer in one line. I know that. And many of you probably did on homework. So the first question you might be asking is, do I really have to do all of this, even if I could do it in my head? The answer is yes. Yes, please. Like, again, it's not about punishment or critique. If you didn't get all the points yet in your homework, you're going to get them. Don't worry. Like, everybody still has totally an A in this class, I promise. But I am saying, if you think this question is easy, all the more reason to start practicing showing all your steps this way. Again, if the question is easy, then there's nothing hard about doing these steps. Well, at worst, you'll feel like it's a waste of your time. At worst, you'll feel like I'm insulting you by making you drag this out when you can already see in your head. But that's at worst, right? Like, it won't cause you stress. There's nothing stressful about any of these steps. What I'm really asking you to do is, if you got this answer really fast in your head, I'm asking you not to insult your own intelligence, but in fact, compliment your own intelligence. If you got this answer really fast in your head, the reason I'm asking you to show all this work is not because I don't believe you, and not because I think you cheated, or not because I'm like, no, I don't want you to recognize, I don't want to recognize how smart and fast you are. What I'm saying is, if you got this answer really fast in your head, that means you can compliment yourself for being so quick at navigating through a multi-step mental process. Like, there's no way your brain could get this answer unless it actually did do those steps. If you think about it, like, to get negative 30 as an answer, your brain had to know that f equals negative kx in general. And then your brain had to apply that general truth to this particular example of 200 and 0.15. So what I'm asking you to do is recognize, in fact, that the smartness in you is not, you didn't have a crystal ball. Jesus didn't come to you or Moses or whatever, didn't come to you in a dream and tell you this answer. You ran a movie in your mind that was 5 frames long, and you zipped through that movie so fast that you didn't think of it as a movie. You just thought of it as a photograph. That's how smart you are. What I'm saying is, slow down that movie and show yourself and me all the frames of that movie, because a day is going to come when we don't see. And maybe it already did for some of you. And maybe some of you already got stressed. Like, what is he expecting us to do this homework already? Like, I didn't even take calculus or whatever. A question is going to come eventually in this homework or others where you look at it and you be like, I have no idea. I mean, I totally know that. Like, and it happens to me. You could look at question, whether it's question 4 on this homework or question 6 for all of us, or if it's question 7 on the next homework. All of us are going to get to the point where we look at a question, and at first our response is, I have no idea. What the heck? I have no idea what to do here. What I'm kind of saying here, Sigli, is, oh, yes, you do. When you say you have no idea, what you really mean is, I can't foresee the final answer as quickly as I'm used to foreseeing, because I'm a smart person. And I'm so smart that when I don't see everything instantly, I kind of feel a little bit stupid, and I don't like that. And so I'm either going to lash out at myself and be like, oh my God, I'm so dumb. I have no idea what's going on here. Or I'm going to lash out at the professor and be like, are you like freaking out of your mind asking me this? Like, how unfair are you to ask me something where I do not even have any idea? I'm here to say, like, no, it's neither your problem nor my problem. It's not a problem. You don't have no idea. You just don't have a complete idea yet. And you'll get a complete idea is if you break down and you go, oh, well, the reason okay, here's the facts that he gave us. Okay, I have no idea. Oh, well, if you say I have no idea how to answer this question, at some level, you're admitting you get what the question's saying and you don't yet have an answer. So write down the question. And then if you're like, oh, the question, anyway, you get my point. So I'm saying to everybody at this stage of the game, even if you can get right answers, if you don't do these methods, I will take off points on the homework temporarily. I want to see each one of these steps, especially practiced when you think you are getting answers. So even if you have right answers, you could lose points for not having these steps. But conversely, anybody who does all these steps on the homework, on every problem, if you do all these steps, even if your answer is totally wrong, you're going to get all the points. It's about doing these steps, not because chances are the more you do these steps, the more you are going to end up getting right answers anyway. But okay, so it is about these steps. It's a 5-point method. I mean, a 5-step method. Those are the acronyms. You know, if ever, please like refer to this PDF or this video later on if you ever start getting homework back and not knowing what acronyms mean. I'm also, before I go on, and I'm going to move faster and faster, obviously, but before I go on to the next questions and start applying this, I have a couple other acronyms that you might see on their homework. Let me just alert you to right now. If I ever see, if I ever write, if I ever write www on your homework, that's a shorthand for I'm saying you skipped a lot of steps. Like if you just skipped a whole bunch and I just write www, I'm really saying like, wait, what? Whoa, what's going on here? Generally speaking, I write www if someone just writes down an equation that I don't know where it might be right. It might be right, but I don't know where it's coming from. I don't know how they chose that equation. I don't know what it means. Like maybe we've never even said it in class. I don't know if the person who wrote it knows what it means. Frequently, basically, if you just get an equation from Chegg or something and you just like copy it down and put it, I'll write www. It's my way of saying like, whoa, you got to back up and justify it. Okay, that's www. Similarly, if I write wwd, this is a much more positive kind of thing. If I write WWD, what it means is I tend to write this if people write questions in their homework or some confusion, they say, I don't understand this or blah, 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 or I got this, but I feel like it should be that. If I write WWD, what it means is totally fair point. No, I totally see why you're raising that, or I see why you're confused, or I see the issue that you're raising, but you are not crazy. You're not alone. It's such a big issue that a lot of other people are going to have this issue too. Wait for class and we're totally going to discuss it. Okay. That's what that means. It sort of just means I don't have time to like give a whole big response right here because then I would have to do it in everybody's. So WWD means you're onto something. You're not crazy. We will discuss. So WWW is kind of a bad thing. WWD is like a good thing. And if I write, I think there's only one. Okay, BCF just means be careful. It's kind of a catch-all. Like if I think you're on the right track, but you're like dropping negative signs or something like that. BCF just means be careful. And YOW means your own words. Be very careful with that. Like when in doubt, whenever you can, put things in your own words. They'll never be 100% different from mine, but the more you can put things in your own words, the more you're showing that things are filtering through your brain and not just through like the internet or whatever. Okay. So we have 12 minutes. So again, those are just like, this is partly I'm trying to show you a method for knowing what to do when you don't know what to do. It also kind of gives you less excuse, right? Like, oh, yeah. No, good question in the direct chat. Yeah, generally speaking, if I put an acronym, it probably means that therefore I took off some points. It's probably the reason that you lost some points. Generally, it does mean that. So yeah. But again, I want to remind everybody with everything except for actual exams, losing points it just means I'm saying here, if you want to get all the points, here's what you have to do. It's me everybody can get all the points as long as they're willing to keep trying and revising. The clock will never run out on the points. That's a subtle thing, but So it's not losing points. It's just like the points that you haven't gotten yet, if that makes any sense. But yes, so in order to get a full score on a homework, you have to like do all the steps. So if ever you don't get a full score on the homework, I'm saying still some steps are not there, but just as long as you have the time and the energy, just then resubmit the homework with those steps and you'll get the points back. If that hopefully makes sense. Okay, cool. Thank you. All right, great. One really underlying lesson of all this, especially when it comes to exams, the one thing that I'm trying to teach everybody, ultimately over time, nothing is instant, but what all of this 5-step method and acronyms and all this, it's really to get people out of the habit of leaving anything blank. The one thing that will ultimately not be very sympathetic to, especially like by the time we get to the final exam, is don't leave anything blank. You want to eventually always have something to say. And this gives you, okay, cool. This is a way of giving you something to say, even when you think you don't have anything to say. Because really, I'm sure you've been there. Science students all the time, they either totally know it, or if they don't, they say, I have no freaking idea. And there's like a whole middle ground that's getting skipped there, right? Like, so we're trying to show you what ideas you always do have that you can put down, even when you think you have no idea. And eventually the ideas that you put down will turn into a full idea. Anyway, you get my point. Okay. All right. So I've got like 10 minutes. I'm just going to try to cruise a little bit faster through some more of the homework, and then we'll just pick up on this next time. Very quickly though, what was the very last thing you did in lab with Joe? Like, because I'm getting scattered with all the class schedules. What was the last motion you developed, or the last lab that you actually did with Joe last time you met?
Motion 2.
Motion 2, thank you. Okay.
Next week is going to be motion 3, he said. Yeah.
Okay. And motion 2 was the one that's like period is directly proportional. Motion 1 is F equals negative KX.
Yeah, it was like a graph, period and mass.
Great. Oh, great. Got it. All right, cool. So we're still on the same page. Thank you. That's very helpful. And that's totally point. Oh, thank you. And I see the direct chat. Thank you guys. You totally get points for that. That's awesome. All right. So I have time to do maybe like one more of these homeworks, but again, we'll all catch up to each other. You are ahead of me, not the other way around. So the next homework question 2. Hello. Come on. My stylus is a piece of garbage. Okay. So now we're on question 2. All right, just to keep going with the method, I'm going to say see above or see previous page. See previous page for diagram. Like you can do this, right? Because we don't have to draw the diagram every time, but I'm just referring to it. Okay, so that's like step 1, right? I just did. Now, step 2, I have to say what the question is. The question here, I believe is at t equals 0, what is the acceleration, right? I believe that's the question. And I could phrase the question that simply if I want. And I want to know the acceleration at t equals 0 at the beginning of the problem, i.e. I want to know the instantaneous acceleration, not the average. I want to know the acceleration at that moment. So I didn't put a bar over it. It's just like literally the letter A, right? I believe that's a question. So I've done step 2. So now I'm going to do step 3, which is I'm going to, even if you could do this in your head, which I'm sure many of you can, I'm going to write down the general principle or definition. Well, F equals negative KX still applies, but it's what I used in question 1 to get, at t equals 0, x equals 0. So we got F equals 0 in question 1. But what's really applying now, what's kicking in now that we haven't used yet is this, right? Newton's second law. Like I'm writing it. I mean, I'm sure most of you used it to do this question, but I'm writing the law now. Also notice I'm writing it sort of carefully. Like it's not F equals MA. It's the sum of all of the F's equals MA, or F net equals MA, right? But that's the law. So here's the 2 general principles that I'm using now to get this answer. Well, I guess I'll go to the next page. Now I can plug in values. So so now I'm applying to the particular problem. I'll say here, t equals x equals 0. We found out that F equals, in fact, I'm sorry. One last thing. right? Really, in this prop, like the sum of all the forces acting on any object equals ma. Like that's Newton's second law. In this case, the only force acting on the object is the spring force. Like, so we have Hooke's law. We have Hooke's law for a particular spring, and we have Newton's second law for how forces work in general. So I put them together and I say, okay, in this case, when you have a spring acting, the spring force produces the acceleration, right? So now I'm in the position to plug in. However you want to say it. So in other words, 0 equals ma, 0 if you want to be really technical. And again, I'm dragging this out partly because I'm the teacher, but also to get you in the habit. So therefore, okay, A equals and I'm not saying that in your homework you have to write step 1, step 2. You have to do all the steps. You don't have to label them 1, 2, 3, and 4, and 5. I'm labeling them here just to get you used to them. You know, I'm just saying you have to do these steps. So the answer, the final circle answered, the final answer circled is A equals 0 meters per second squared. Notice there's units in that final answer. Notice the final answer is a complete thought. It's a statement. Like the final answer is not 0. The final answer is A equals 0 meters per second squared. Notice it links back to the original question. The original question is, what is the acceleration? The answer is the acceleration is 0 meters per second squared. Like, again, honestly, if you did all, even if you got this wrong, if you got that A was like 5, but if you literally got to the point where your final answer was A equals some number with proper acceleration units and you circled it, you get full credit for that, even if, you know, even if the number was wrong, because you showed that you actually did answer the original question. But okay, so that's the answer to that. I'm sure we have to, yeah, this is a perfect place to end. And then the next question, we'll just end with this next one. I'm just gonna do it fast. I'm just gonna write it fast. I'm sure you got it right. Things start getting a little harder at question 4. By the way, if anybody wants to, well, anyway, I think they start getting harder, but it's still, so right now we're doing forces, accelerations. By the time you get to question 4, you have to start thinking about energy, which is still a good old physics idea from physics 1, but sure, it makes it a little bit harder, but we're still just all in the land of physics 1 here. But question 3 was, question 3. Oh, what is, I don't remember. Wait, what is, oh, yeah. Wait. Oh, I'm sorry. Wait, I'm sorry. I just skipped. No one's protesting. I just skipped the question accidentally. Sorry, let me go back. This is at t equals. Sorry. I'm sort of surprised no one corrected me here, but. Right. I mean, am I crazy? Or I mean, I kind of skipped. The answer to this question is negative 100 meters per second squared, right?
Yeah, that's question 2. And you moved on to question 3, which is
Yeah,
like,
sorry. Right. Totally. Yes. Thank you. I'm sorry. Yes. So the answer to question 2 was meant to be negative 100 meters per second squared. My bad. Sorry. And don't mean to confuse people. It was negative 1 because question 2 was what's the acceleration at the very beginning of all this. Notice I get a negative answer, and this goes back to, it might have been Julia's, yeah, it was Julia's thing. Notice I get a negative answer again. The acceleration is negative. That does not necessarily mean the thing down. All right. Oh no.
that the mass is slowing down.
It doesn't necessarily mean that it's slowing down. It might, it actually isn't slowing down. It's actually speeding up, but it's speeding up to the left, like you said 5 minutes ago. In other words, because the right-hand direction is the positive direction. So this thing is, it's speeding up, but in the leftward direction. That's what the negative means. just like you said before, the negative means to the left. It means that the acceleration is to the left. And acceleration to the left either means speeding up while something moves to the left or slowing down while something moves to the right. Maybe I'm saying that too fast, but I think we're about to be, I might want to pick up on that next, but the answer is negative. And the object is actually speeding up. Yeah, it's speeding up from a speed of 0 to what we're ultimately going to find to be a speed of 3.87. But all right, I know class is just about to end. So this is the answer, negative 100 meters per second squared. And then the answer to question 3, or the question of question 3 is, what's a at x equals 0? And this is the one that I skipped to a second ago, like Yulia said. We will pick up from here next time, but that's started. So I know that was confusing that I did the questions out of order by mistake, but that's, let me just see. Frame of reference, very good. Yeah, very good, Sasha, actually. Okay, sorry about the confusion, but that's it for today. I mean, I'm done. I'm going to hang out for a second if there's any questions or anything, or if you want to copy notes, but you guys are good to go whenever you want. I very much enjoy this class. I appreciate your indulgence. Oh, okay. Oh, that's that's an interesting. Sorry, no, okay, there's a couple of questions in the direct chat. I owe you guys homeworks. I fell behind. You will receive grades soon, like probably this weekend. It's totally my bad. I fell behind with all the holidays and everything. All the holidays we just had are holidays that my family celebrates. So I observes. So I was actually so I'm behind on homeworks. You will get them probably this weekend. I apologize. And then as far as thank you. All right, thank you. Then as far as the game, this is another question in the direct chat. The game portals are scheduled for October 1st. We only have one more class. Let me think about that. I mean, yeah, I'll probably extend them. Yeah, the game portal thing I'll think about. I'll probably extend those deadlines. Yeah, I see what you're saying. Okay, thank you.
Professor, just a quick question.